Welcome to ZapTech. Today, we're going to explore the batteries of the future, these energy reservoirs that could, in the near future, be recharged in just a few seconds. You heard that right, a few seconds compared to several hours today. Between promising innovations and technical challenges, we'll see how solid-state batteries, sodium-ion technologies, and graphene batteries are gradually reshaping the landscape of electric mobility and energy storage. But before we set off on this new adventure, don't forget to like the video and subscribe to the channel so you don't miss anything. To understand why these new generations of batteries are generating so much excitement, let's briefly go back in time. At the beginning of the 20th century, electricity was still a luxury. Lead-acid batteries dominated and weighed a ton. Then, in the 1990s, lithium-ion batteries came along and revolutionized the world of portable electronics, computers, phones, cameras. They made miniaturization a part of everyday life. But while lithium-ion batteries have enabled immense progress, they have now reached a certain technological ceiling. Problems with energy density, risk of overheating, limited lifespan, dependence on costly or hard-to-recycle materials. These are all constraints driving research to constantly innovate. It's important to understand that in a battery, electricity is stored in chemical form. When you recharge it, you force ions, often lithium ions, to move from one electrode to another. And during discharge, this process reverses to power your device. Challenge number 1, energy density. The higher it is, the more energy the battery can store for the same volume. Today's lithium-ion batteries have already made huge strides, but to power an electric car for hundreds of miles, we need to increase capacity even further and ensure safety. Challenge number 2, charging speed. Forcing ions through faster can cause damage, like the formation of dendrites, small growths inside the battery that can lead to short circuits and therefore explosion risks. The first major line of research, solid-state batteries. In a conventional lithium-ion battery today, the electrolyte, the medium in which ions move, is liquid. This part can leak or catch fire if damaged. In solid-state batteries, this electrolyte is replaced by a solid material, often ceramic or a special polymer. The advantages? Potentially higher energy density, because more lithium-rich or thinner electrodes can be used. Increased safety, since a solid electrolyte is less flammable than a liquid. Slower wear, promising a longer lifespan. However, it's not that simple. Current solid materials sometimes struggle to conduct ions as effectively as a liquid, and they can crack or lose performance after several hundred cycles. Researchers are working hard to refine the structure of these materials, to speed up ion diffusion while maintaining great stability. Some startups like QuantumScape, backed by automotive giants, claim to have partially solved these problems. Early demonstrations suggest batteries that could recharge to 80% in under 15 minutes, offering ranges greater than current batteries. Another promising avenue, sodium-ion batteries. Instead of using lithium, they use sodium, an element abundant on Earth, much cheaper and easier to extract. The chemical principle remains similar. Sodium ions move from one electrode to the other. The advantages include more secure supply and potentially lower manufacturing costs. We could therefore imagine, for stationary applications or for vehicles with lower range requirements, a massive use of these low-cost batteries. However, the energy density of sodium-ion batteries is still lower than that of lithium-ion batteries today, and researchers still need to prove they can handle enough charge cycles to compete on a large scale. Since the discovery of graphene in 2004, this two-dimensional material composed of a single layer of carbon atoms has continued to captivate industry. Ultralight, ultra-strong, and superconductive. Graphene has it all. In batteries, it can be used to improve electrodes, thus increasing charging speed and battery life. In theory, an electrode coated with graphene can facilitate ion movement, like a 3-lane highway compared to a single-lane road. However, producing high-quality graphene in industrial quantities remains a challenge. The processes are still expensive and not always easy to scale up. That's why graphene is currently found in only a few niche applications and rarely in consumer batteries. The idea of recharging in a few seconds is no longer pure science fiction. Some university and industrial laboratories have already demonstrated battery prototypes capable of taking in a high amount of power in a very short time. How? By working on the contact surface, nanostructured electrodes that multiply the channels through which ions can flow, by developing more conductive electrolytes, including hybrid solid-liquid structures, and by perfecting the battery's electronic management to avoid heat spikes and mechanical stress. Nevertheless, these innovations still need to prove their commercial viability, manufacturing costs, real durability, compatibility with current standards, and let's not forget charging infrastructure. Having a car that can recharge in 30 seconds is only useful if the charging station can provide the huge amount of power needed in that short time frame. Batteries have already revolutionized our daily lives. They allow us to communicate, travel, work, or be entertained away from power outlets. But the next major step is looming. Batteries with greater range that recharge in a flash and offer increased reliability. Whether they are solid-state batteries, sodium-ion, graphene, or other yet unknown technologies, scientific excitement is at its peak. Of course, there is still a long way to go, full of obstacles, technical challenges, resource availability, infrastructure adaptation, yet the collective interest in clean, sustainable energy solutions remains strong, and every discovery brings us a little closer to a future where the battery is no longer a constraint, but one of the pillars of our daily lives.